Hello, everyone. Yeah. Hello, Anita.
Hello, hi.
How are you today?
I'm doing good, Tatiana. Thank you. How
Yeah,
are you?
I'm fine. It's pretty hot in our location. What about you? Seems so.
Yeah, at my place it's always hot. It's hot, hotter,
Yeah,
hotter.
yeah. You got used to it. Okay,
Yeah.
so I see that we're waiting for some people to join us, and we will
Okay.
start like in 1 minute or something. Yeah,
Oh,
and
yeah.
yeah, we will start our topic, our webinar today.
Okay.
Okay, I see you're smiling, so your mood is fine.
Yeah.
That's cool. All right. Okay. I think we can get started. So today we have Anita from India, and she will share her experience regarding Internet of Things. I think it's a very fresh and interesting topic, and I don't think we even covered this topic before. So I think that today we will have a very interesting discussion. And yep, Anita, the floor is yours. And you can also, and just some words to our audience. You can ask the questions in the chat in YouTube or in their community if you are watching there. So please do not hesitate to ask any questions and we will answer them in the end of the session. So thank you. And Anita, the floor is yours.
Thank you. Thank you so much. Welcome, everyone. So, today I wanted to talk about IoT. We'll cover the basics and specifically the role of BA in IoT projects. Let's quickly dive in. Quick intro about me. I have 11 plus years of experience in IT, and primarily I've been a BA around digital transformation projects for supply chain, particularly specializing in process improvement initiatives, AI, and emerging tech solutions across other sectors as well. So today we will be covering from the basics what is IoT, where is IoT used, the different applications of IoT, how IoT systems work. We'll see a very basic architecture to understand how IoT systems work and what is expected out of a BA in IoT projects and where you can learn more or upskill yourself for IoT projects. So let's quickly move on. So, what is IoT? IoT is basically Internet of Things. This might seem like a far-fetched topic, but it's almost ingrained in our everyday lives. If you come across any of these devices in your everyday life, like the smartwatches or robotic vacuums, the virtual assistants like Alexa, Siri, or even smart thermostats. Nowadays, you have smart devices in almost every category, from smart refrigerators to smart ovens. Most of these devices work on the principle of IoT, Internet of Things. So, what is IoT then? It is basically means that we are connecting all of these devices from the physical world to the internet. Previously, historically, when we started using internet, we were exchanging data or information, and mostly it was the humans who were sending information from one place to other. We send emails and we transfer or exchange information. Nowadays, we are collecting data from these physical devices and putting them onto the internet so that we can make better use out of these devices, making them smart, making them to you get more use out of these devices. So that is pretty much the high level definition of what IoT is. Now we'll go a bit deeper. Internet of Things, the main two words here, Internet and Things. If we break these down, we'll see what things are. Things, like we spoke about, are all of these devices. So this could be any of the device that we spoke about earlier. All of these devices have something called some sensors which collect information from the physical world. This could be monitoring the temperature, this could be monitoring the proximity, this could be monitoring the humidity, or any of these characteristics from the physical world. So we are gathering data using these sensors, and we can actually control these devices using something called the actuators. So these devices, the actuators are could be like the switch of your AC, could be like any other elements of that physical device, which can control the temperature. You can change the temperature, or you can switch on your AC before you even arrive at your house using these IoT devices. So then when we see about internet, it means that once we collect all of these data from these things, we are putting them onto the cloud, we are putting them onto the internet, so that we can process this data, and we can make use of these data, we can analyze this, and we can actually understand or dispatch some request. You can say what next action has to be taken based out of this analysis that you've done on the data. So this could primarily be on cloud, and this also has another way that we can do, which is called edge processing, which means the data is computed locally near the devices. That's why it's called edge. This has primarily few advantages because the number of devices are growing, the number of places where we are using IoT is growing. We collect large amounts of data. Sending all of this data to the cloud and processing all of this data consumes a lot of bandwidth, and it also might cause latency while we are processing this large amounts of data. That is why we compute the data locally. For example, if we are collecting data from a temperature sensor, we can only send data to the cloud when it crosses beyond a range. Say you are monitoring the temperature from your home using your smart thermostat. If the temperature is beyond, say, 25 degrees Celsius, only then you will pass the data to the cloud so that you can take some action out of it. If it falls within the 23 to 25 degrees, you're not going to take any action, so it works fine, then we will not pass this data onto the cloud. So this is called as edge processing. This is how we make sense of the data that we collect from these things or the devices. So while we understand what is IoT, and we primarily know that most of these applications, what we've seen in our real life, like I already mentioned, the smartwatch, the smart speakers, or the voice assistants like Alexa, Siri that we have at our homes, or the robotic vacuums, or any other smart devices, all of these fall under the bracket of consumer IoT, wherever we directly as consumers interact with these devices. There are other applications at even larger scales at which IoT is utilized for. One another thing is the commercial IoT. So think of the same examples that we used for temperature tracking. When that is applied to a larger setting in a commercial building or a commercial space, that becomes commercial IoT. Say, for example, when they want to analyze from when the workers are entering into the factories, if they are not wearing the hard helmets, through some motion trackers, through some for safety monitoring cases, those kind of applications come under this commercial IoT bracket. And then for industrial IoT, where there are large machineries involved, they want to track whether the machinery is performing as expected, and we can even predict whether the machine is going to fail or there will be some problems with the machinery. These kind of cases are used in industrial IoT scenarios, and also increasingly IoT is being used in agriculture as well. In smart agriculture, there are many cases where you can track the soil moisture, and then accordingly you can water the plants and automate the watering, and then you can monitor the crop health in real time. All of these use cases come under industrial IoT in a very large scale. And the even bigger scale, we have the infrastructure IoT, wherein smart cities and smart grids are being used. Smart grids for efficient power usage, using sustainable resources. All of this, even connecting the entire transport network, or monitoring the parking, and all of this at a city level, at even bigger network level, all of these are falling under the infrastructure IoT. So obviously, apart from what we've already seen in our real lives, there are many more use cases, and most of the companies are already exploring or even implemented most of these at few levels. So it's good for us as business analysts to be aware of these IoT applications and how IoT works, so that we can be equipped when we get a chance to work in these kind of projects. So, with that said, as a BA, it's important for us to understand how the IoT systems work. We'll start with a very basic architecture. We're not going to go into details or more nuances here. This is just a very simple architecture where we have four layers. So the first layer, from the bottom, we have the sensors. Like we already spoke, the sensors gather the data from the physical environment. It could be your temperature sensors, humidity, motion tracking, all of these proximity sensors. There are various types of sensors depending on what we want to track. So all of these form the first layer. Then we have the gateway. Gateway is where we have the data collected from the sensors before we pass it on to the cloud. Like we spoke about edge processing, right? A gateway is one type of device that is used in edge processing or edge computing, wherein before we pass on the data to the cloud, the gateway acts as a central point where all of the data is locally processed and aggregated. In certain cases, some rules might be applied, some initial analysis might be done, and then it will be passed on to the cloud. Say, for example, in a smart building scenario that we saw earlier, there could be a building. We want to track the temperature sensors and installed across the different floors of a large building. So there might be gateways installed at each level, for example, depending on how the system is defined, how the hardware is defined. Say the gateway might be, there could be 100 sensors in a floor, and there might be one gateway which aggregates the data from that particular floor, and then it's passed on to the cloud. So that is one example of how gateway comes into the picture here. And then the next layer is the cloud, where we send all the data that we get from collect from our gateway into the cloud, and the actual processing takes place on the cloud. There are We can automate security alerts. We can automate alerts when the temperature is going beyond certain limit, or there are some that doesn't comply with what we are monitoring, right? So those kind of alerts and actual processing of the data and everything can be done on cloud. And then we have the application interface, where it's similar to how we have in any other application. This is where the end users will come into picture. Say, for an example, in the smart building scenario, there might be the IT infra admins or the support personnel for that building, right? So they will have the view of to monitor the temperature across different floors if anything needs changing. There could be ways there where the alerts are just given to them and the people have to take action, or there can be actually automated ways, when we saw the actuators in the earlier slides. So when the temperature drops, there could be an automated system where the actuator is triggered, and then the temperature comes or again is brought back to the appropriate levels. So this is how the IoT architecture is structured. So as a BA, we might have been exposed to this application layer or cloud layer already. So in many of our projects, we might have dealt with the requirements at these spaces. I want to focus on how we can, as a BA, contribute for the IoT project when there is this additional layers that are involved, how we can contribute and what is expected out of the BA in these cases. So let's dive into that with a case study. This is something that I've worked on in my past projects. So consider this client was a dairy processor. They were actually collecting milk from the farms and bringing it into their factories where they process it, and then all the pasteurization, all the other after the processing is complete, they package it and then they send it on for the dispatch it to their warehouses again. For the supply chain process goes on from there. So the key challenges they had where they were not able to track the vehicles which carry the milk either from the factories to from the farms to the factories, and from factories when they are traveling back to the warehouses to the wholesale distributors and other locations. They wanted to be able to track these vehicles in real time if they want to provide any support to the truck drivers on route optimization, or they want to identify and track whether the milk that they are carrying is of the right quality, whether it's maintained in the right temperatures in the cold storage. So the goal was to ensure the freshness and quality of milk. So how do we do that? We had certain temperature limits that the cold storage should be maintained. For this varied based on different states. But when we initially piloted, it was targeted for one location. We wanted to ensure that the milk right from the starting point till where when right from the starting point, which was the farm, to the factory, the temperature is maintained consistently. There was no way we could monitor this in real time before this project. So that was the main goal here, and also optimize delivery routes for the truck drivers in case there was some issue or some accident, or they want to take an alternate route, or there was a vehicle breakdown. How we monitor that and guide the truck drivers. So these were kind of the problems that we wanted to target. So how we approached this project was we had a dedicated discovery session, and then we started on from there. So I'll go through the typical phases which are unique to this IoT project. I'll not be covering into what we might do in any other project as well. So the main difference, like I spoke earlier, was on the hardware setup. Without hardware, there's no data that we can collect, and there is no IoT project itself. So the hardware setup is the crucial thing. Though there might be hardware engineers and specialists also involved, the hardware vendors are also knowledgeable in this area. What a BA might do in this case. So what happens in this hardware setup is typically based on the business problem, we'll have to identify what type of sensors are required, how many sensors might be required, what configurations should go into that particular sensor. And based on it could be based on the regulatory standards, it could be based on the product that we are trying to monitor. Say, there are different temperature requirements for dairy products. This is for seafoods or for fresh produce. There are different temperature regulations that has to be followed. So based on this, the sensors have to be installed and set up so that we are able to gather data from that. So this is the first part that happens in the hardware setup phase. So as a BA, what we will do is the critical thing is to explain the hardware team, the hardware specialist, what the business requirement is. So in this case, we want to monitor the live location of the truck, and also we want to monitor the quality of the milk. So we want to ensure that the temperature is maintained across. So these are the primary two requirements for this case. So based on this, we know that we need a GPS tracker for location, and for a temperature sensor to calculate the temperature or the timings or the temperature of the milk that is being transported. So apart from this, where the sensor has to be placed to optimally collect the data, and how the what type of edge device is required, and how the connectivity between the sensors and the edge is established. All of these is what the team takes ownership, but the BA should be there throughout to support on what the business requirement is, on what the business need is, so that they can choose the ideal hardware devices for this step. Like I mentioned, for this case, it was a range between -5 to +5 degrees. So we have to set the accuracy to plus or minus 0.5 degrees for that sensor. Only that accuracy. If it is plus or minus a 0.5, it's okay, but it cannot go beyond that. So the temperature sensor, based on the accuracy limit that we set, it should be able to collect the data within that accuracy limit. And it based on there are various other factors, like the life of the sensor. Based on the accuracy impacts the life of the sensor, like how long it can collect the data and all of that. So based on the requirement that it can not go beyond plus or minus zero point 0.5 degrees, this will impact what kind of hardware is being selected for this project. So primarily it's the role of the BA to just understand the business requirements from this context and collaborate with the hardware team to ensure the hardware setup is done efficiently, so that the next steps can follow. We get the data and follow from there. So the next step is on the edge and the cloud platforms. Obviously, in this stage, we are setting up the edge, we are setting up the cloud. Based on the cloud provider we are going for, could be Azure, AWS, or any other providers which give all of these IoT edge capabilities out of the box itself. Again, supporting the solution architecture team to understand what kind of requirements we are looking for here. Based on whether we need real-time updates. In this case, we needed real-time tracking of the vehicle. So in this case, based on that, we define that the data transmission frequency should be every 1 minute. So these kind of settings will be done on the edge device, on the edge software. So all of these will go into the requirements. And Then again, cloud integration with the application that we are building and any other systems that we want to integrate with. We should be able to understand if there are any other possible integrations that will come in the future. Say, for example, once the truck arrives at the factory, are we going to integrate it with a warehouse management system or any other existing systems, so that we can check initially whether the cloud provider that we are choosing, say if we are choosing Azure IoT Edge, we can ensure that this is compatible with all the other existing systems that they have. If already all of the existing systems they have, or any other standalone applications are running on a certain type of infra and it's not compatible, it might be a problem later on. So these kind of things are what the BA should take care of in this space. And next comes the alerts and analytics. Few kinds of alerts can be configured within the cloud itself, and then few custom alerts, or what kind of visualization we want to see. Say, for example, we are tracking the truck in real time in live. So we want to see a map view, and we want to see where the trucks are, how many, which region you want to see, at how many trucks you want to track in one view, all of this, right? So different kinds of visualization requirements, and also integrating this with any other existing application that we have, or using some other out of the box system itself. Like for example, there are transportation management systems and various providers like Blue Yonder and other providers who give this out of the box transportation management systems itself. So in that case, we'll just have to integrate our data from the hardware to the cloud, and then integrate that with the TMS system, and then we'll be able to get our visualization. But if we are building out of from scratch, then we'll have to, as a BA, we'll have to ensure that all of these data visualization requirements, and what we do out of the data, once we have the data, how we use it for optimizing the routes and other things, and what alerts we want to give. These are basic stuff, whether we want to alert through message or email, or in this case it's real time, so obviously we went for messages and mails. So how we interact back with the truck drivers, what kind of data is being maintained, all of this comes here. So yeah, all of these vehicle tracking and process optimization will come into this space. This is mostly similar to what we would see in any other data project, but just that we'll have to consider what needs to go here should be determined prior, so that we can inform in the earlier stages itself that this is the data that we want to show here, and we ensure that that data can be collected from that type of sensor, and we ensure that the connectivity is there and the data we are bringing in is supporting the kind of visualization that we are looking for. So finally, security and compliance. This is a very critical topic in IoT projects because of the connected nature. There could be data breaches anywhere, and apart from any other regular projects, the security and compliance plays a huge role in IoT projects. In this case, we had only the personal information of the truck drivers maintained in the maintained as like a personal information, identifiable information that we could track. So we had to have the data security and other data privacy standards applied for that. Apart from that, whatever data we collect from the sensors are also supposed to be assessed regularly, because we need to ensure that the data that is collected from the sensors are reliable and right, and we are performing the analysis based out of that data. So there are if for example, in our case, if we are going for Azure IoT Edge, there are sensor diagnostics tools that are available on the software itself, which can validate the accuracy of the sensors. Which can validate whether the sensor is actually producing the data in the set accuracy that we had defined initially. So apart from this, like I mentioned, the regulatory requirements for these kind of products vary. This could vary based on different states even, and for different kind of products, like for a dairy it could be different, for fresh produce it could be different. Even within dairy, the raw or unprocessed milk has some other temperature, and once it is processed and it's packaged, there is another temperature requirement. So all of this has to be considered when we are defining the temperature requirements at each stage. And then yeah, so that is on the regulatory compliance and the data quality. Like I already mentioned, the security and the quality standards, the encryption, all should be considered, because in this case it was only the some amount of data on the truck driver's personal information. But in any other use case, it could be that we are dealing with a lot of data. For example, in healthcare, there could be patient related information which is required that we maintain the confidentiality of the data and all of that. So we need to ensure that this is considered there. So with that said, the intention was just to give an overview and to understand what could go into the IoT projects. There is a lot more to uncover in IoT projects, and it's the trend is only growing from here. This is a recent statistics that I saw, that the devices are going to grow almost double from what it's already there. So this it's going to be like 32.1 billion IoT devices in 2030, and obviously there would be more scope for IoT projects, not just what we see in the consumer IoT landscape, but in all the other arenas like we saw earlier. So how can we be prepared more for this? There are various introductory courses on IoT available. So we can take any one of the courses. And also about IoT trends, there are various blogs that capture all of these trends in IoT segment wise in different industries. So that will be useful to understand how it's impacting if you are specializing in a specializing in one particular industry. What are the trends within healthcare or supply chain that will be helpful to upskill in this field. And also there is this blog that I find very useful, IoT for All, where they have different IoT case studies in your industry or a specific domain, be it from aerospace to agriculture to all of the mostly all domains they've covered. So I'm mentioning this because you can take a look at the different type of case studies, and it would be useful if when there is a chance you could pitch that this as a probable case in your project, that if there is a scope, you can say that this kind of technology can be implemented, because most of the companies now are looking for AI, Gen AI solutions, and IoT could be a potential case study that you could introduce in your project or domain as well. So with that, I think that's all I had for today. I'll be happy to take any questions if there are.
Yeah, thank you very much, Anita. Thank you for your presentation. That was very, very interesting and helpful, I guess. And everyone will know more definitely about Internet of Things. And for now, I don't see any questions so far in the chats, but everyone can see the contact information of Anita, so you can ask her offline if you have some questions or might have in future. So, and I think we're done for today. Thank you very much for your participation, for your presentation, Anita, and
Thank
have a good
you.
day.
Thank you. Thank you all. Thank you, Tatina.